Welcome to our review on sound properties and uses. So the first thing we actually need to understand then is what happens when a wave is going from one medium to another. So what we'll actually find here is that the first thing that could happen is something called refraction. And I've given you a little picture at the bottom to demonstrate this. So what we can see there is a pencil in a glass of water, but it doesn't look like it's in line anymore. And that's because we've actually refracted the wave. Because what's happening there is the wave is travelling from one medium, air, into another medium, water. And what we're seeing as a result of that is the velocity and the direction have changed to give us a different image. So if we consider refraction in more detail then, what we actually find is that if our wave is moving from a less dense medium like air into a more dense medium like water, then the wave is going to slow down. And as it does so, assuming it's hit at an angle, it's going to bend towards the normal. And hopefully we remember that the normal is that line at 90 degrees to the surface. Now, what we'll find as a result of this is that the actual wave is going to bend. Okay. Second thing that's going to happen is the wavelength is going to decrease because we're going into a more dense medium. That means that those waves are going to get closer together, therefore decreasing the wavelength. However, the frequency stays the same because what we've actually found there is that our velocity has decreased, the wavelength has also decreased, so therefore the frequency remains the same. So I've given you a little diagram on the bottom left there to show you how this would be drawn in terms of a ray diagram. And you can see that each of those bits that have hit through the boundary, that blue line is our boundary, then show that they've changed their direction. And you can see that the space between them has also changed because what we've seen there is a change to the wavelength. Perhaps an easier way to think about it, if you're struggling to sort of visualize that, is if we've got a whole load of people all marching in a line. If they start off on a concrete surface, it's really easy to march on that. So what we're going to find is that they're going to be able to move nice and quick, all in line together. However, if they then hit this area that turns to sand, those that start marching on the sand first are going to slow down. So what we'll see is those lines are going to start to bend. So what we will see there is a little model that we can use in order to understand this. One thing to bear in mind though when we're talking about refraction is that if our sound wave hits the boundary at 0 degrees to the normal, then we will change speed but not direction. Because obviously if everything's hitting at the exact same time, there's not going to be the bending there. So when we've got a wave that comes into contact with one of these boundaries between two mediums, then three things could happen. So as the wave hits, it could be reflected, which is what we see in terms of an echo. It could be transmitted, and this is one of those possibilities being refraction, or it could be absorbed. Hopefully at the end of this video you can now describe how changes in velocity, frequency and wavelength are related when those sound waves move from one medium to another, and you can describe the effects of reflection, transmission and absorption of sound waves at the boundary between two materials.